this is going on page 81 when we're done, okay? And so we're doing logarithmic function context and data modeling. So just like the other functions that we've done, we got to where we're doing regression. So that's what we're working on here with this one right now. So the average salary for a church pastor across the U.S. increases as the size of the church increases. The graph above shows the average pastor salaries for various church sizes. Okay, I didn't check the data, but Mr. Passwater made this. I'm quite sure it's pretty accurate. So it says we can clearly see a pattern. So I think you definitely see a pattern in the data. But the models we've used previously, linear, quadratic, and exponential, don't fit this, right? So this above shows a large rate of change initially, but then as the church size increases, we see the rate of change gradually decrease, okay? So it appears to be logarithmic, and that's what we're talking about right now. So just as we've seen with other types of functions, again, linear, quadratic, and exponential, many real-world scenarios follow a logarithmic pattern. That's why we focus on these, because there's a ton of functions we could talk about, but these are a lot of our real-world examples. So outside the salary, which is this, logarithmic patterns are found in the way we measure earthquakes, sound, acidity, and many other contexts. So as a result, we need a way to do the regression, right? So something we already know is that our logarithmic function models are how to tell if it's logarithmic. If for your given set of data, if the input values appear to change proportionally, meaning they're being multiplied by 2 or multiplied by 1/3 or whatever, those are my inputs. They change proportionally over equal length output value intervals. Okay, remember that's the opposite of exponential because they are inverses, then it's a log. Okay, or the nice thing is with the, because we're going to look at a lot of things today that really model one of your FRQs. The FRQ isn't necessarily logarithmic. It's going to ask us about this. It is regression, but it could be linear, which I doubt it would be because that seems a little easy. But linear, quadratic, exponential, or logarithmic. I think it could also either be cubic or quartic, which would be easy to fill in there. But we don't know for sure that's logarithmic, but still the same types of questions. The good thing about that is it pretty much is that you could totally have questions on the exam that ask you like, is this logarithmic or is it exponential? But on the FRQ where you have to do this, it will flat out tell you what you're supposed to be using. So in this case, it says selected values of the logarithmic function are given. And it also tells you what your equation should look like. But this one right here, which could be an option, we are going to mark out because I intended on changing it and I thought I did. And clearly I did not. So we're going to rewrite what I meant for this to be. L of x equals a plus b times log base 2 of x. So basically all I did there was I changed natural log to log base 2. You could have either one. Most likely on the FRQ, you would have a natural log if it's a log, but we're not guaranteed that. But here's the good thing, is that last year, because we weren't using Desmos, we had to know how to do a lot of what we're doing today by hand, a lot kind of with the calculator at the same time, because the calculator will only give you natural log. Desmos, however, can do any kind of log. And there's a way to tell it ahead of time, hey, this is the log I want, but it's actually easier to let it spit out a natural log and then fix it. So that's what we're going to look at, and I want to make sure you know how to do that. So you always, no matter whether it's a log or not, want to pay attention to what they're giving you so that you know that you're using the right thing, okay? So the first part says to use the given data to write two equations. So we're going to write two equations that can be used to find A and B. It does not tell me to find A and B right there. It does not tell me to solve anything. We are going to write equations and stop, like just boop, there it is, okay? So here's, and using this form right here. L of x, which is my output, so in this first line right here, L of x is 3, so 3 equals A plus B, which we don't know, times log base 2 of the input x, which is 2 in this case. Okay, that's one equation. The other one would be 7 equals A plus B times log base 2 of 5. So now I have two equations, two variables. I have a system. I could totally solve it by hand and then have to like put in the last part of the answer in the calculator at the last minute. But we don't have to do that. We're going to do it on the calculator. But before we do, I do want to talk about one thing, because this morning's second period, when I realized I hadn't actually changed this like I thought I did, but again, I was mad yesterday and being petty, so I probably wasn't thinking straight. I don't remember exactly what I was going to put. I just knew I wanted another log, so I just threw a 2 up there. And then as I was writing the equation, I was like, oh, look, it's log base 2 of 2. So what is log base 2 of 2? 1. So really, this is just 3 equals a plus b, right? So if I was solving it by hand, that kind of simplifies it. But we're not going to do that. Even if you can simplify something like that and you get to use the calculator, let the calculator do everything, right? You're just going to let it do it so we don't do anything weird. So now we're supposed to find the values of a and b. So now is where we're going to go to Desmos. And you should have the green bar at the top, because that is what I put into Canvas, because that is the AP version that you will actually get on the exam. We're going to add our table, and then we're going to put in our data. Oh, where is my paper? Let's see, we had 2 and 5 and 3 and 7. And once we can do one kind of regression on Desmos, we can do them all, right? I can hit my little magnifying glass, which you don't absolutely have to, but I do think it's helpful sometimes. I want regression, linear is the default, and I just change it to logarithmic. Okay. Everybody with me? Now, when you do logarithmic regression, there could be a little box that says log mode. If it's there, you click it. Now, if you only have 2 points, you're not going to have the box, because there's only one way to do it, really. And remember, when we only have 2 points, that could be linear, quadratic, like we don't know. And that's why it has to flat out tell us if we only have that. So, but now I look at this, what they gave me. Does that look like what I was told to give? And it doesn't, right? It's close. I got an A and a B, but this says natural log of X. So if you recall, because Desmos has evolved a lot this year once we were told we were going to use it, there were times where we'd get this equation and there weren't enough decimal places. Well, they fixed that. But we started doing this before they fixed that. So I told you, if you don't have enough decimal places, we're going to do the same thing you would do in that case. You hit the little 3 dots and you export as a custom regression. When you do that, it gives you what you would have to type in if we didn't have that little option, that drop-down menu. Like when you did it in Algebra 1 and you had to know how to do the y sub 1 with the little tilde thing, right? But the nice thing is, it'll just give me that. I don't have to know them all. Not only that, but you see my little flashing cursor there? Now I can, since what I want is log base 2, excuse me, I can arrow over, and just go ahead and you can use your arrow keys on your computer even. I just don't have the, and then I can back out the natural log, right? And then you can use your keyboard and type in LOG, but I don't have my keyboard. So you could also go to functions and scroll down to, so I have log and log base A. So I want the log base A, so I can put the 2 in there. And remember, if you're typing on your computer, you type LOG and then shift dash to get the underscore, and it'll drop it down there for you. And then if you notice, you still have the original thing that they gave you, and then you have your new one. These numbers, well, the A part is the same, but B has changed, so make sure you're using the correct one, all right? So this is my A and B that I'm actually looking for right here. And I think I said this once the last time we did something with decimals. I don't like changing the rules in the middle of the game, but I haven't really had a choice because they've been changed on me. And, you know, when we decided we're going to use Desmos, had I known all this before the year started, I would have started differently. We know we have to be correct to 3 decimal places. I have always said we should write down at least 4. But because I still don't think that there's a way in Desmos, and we don't have to do it on any of these questions, but if we do in something else, there's still no way to store a value. So if we have to type back in a decimal, which I've always said is bad, bad, real bad, then we need at least 5. So I'm changing what I'm going to do and what I would suggest that you do, and you don't have to write down every decimal place you see, but let's write down 5, because if we type 5 back in, we should be correct to 3, okay? And again, I apologize for keep changing things around, but it is what it is. So I've got my A and B there, so I know then that A equals, I've lost them, negative 0.02588 and B equals 3.02588. And I went and double checked myself because I thought it was weird that they had the last 4 digits the same, but it's correct. Everybody okay so far? We good? Do we understand how to manipulate that if necessary? It's not always necessary, but if necessary, we need to know what to do to make it match. We good? Beautiful. Okay. So let's flip it over. So here, example 2. The table above gives the data from the graph at the beginning of the notes related to church size. Okay, so this is the data that's actually plotted there. This says use the regression capabilities of your graphing calculator to find the function. So again, if this, because we could totally have data like this that says something similar to this as an FRQ. It would actually start off with write the 2 equations, then find A and B, and then write the equation. But we're just going to kind of do it all in one step. And it gives me this. And it says where P represents the church size, so I'm going to label those, and S is the average salary in thousands of dollars. So then I'm going to go back to Desmos. I'm going to X out what I have. I have never, me personally, I don't have good luck with trying to type over on a table because I always do something stupid. So I think it's better just to start over. And then type in all that data. I'm sure it'll take me longer than it takes you. But when you type in a ton of it like this, be very careful that you're not going too fast and you miss a digit or something. So pay attention because there's so much stuff, it's easy to mess one up. I speak from personal experience, of course. And if you're wondering why I'm not using my fancy little keyboard thing that I was so excited about, it's because I made sure I got one that wasn't Bluetooth, so I didn't have Bluetooth issues. And then apparently I took out the little USB thing from my computer, and I thought I put it back in. Apparently it's not the right one, so in normal me fashion, I've probably lost it and should have gotten the Bluetooth one. Okay. So then again, I'm going to hit my magnifying glass. If you're still typing, that's okay. Do my regression. I need logarithmic regression. Oh my gosh. Let me add some things so that I can move it up. All right. What do I need to make sure I do before I do anything else? Log mode. What did you notice when you did that? Nothing changed, right? I think this is the first time that we've clicked the button and nothing has happened. Because remember, there's 2 different ways to come up with these that are kind of confusing to understand. It's okay if you don't understand it. I have to look it up every time to make it make sense to me. All we know is log mode is what all the calculators you would ever use have. This also does another way, but when you click log mode and it doesn't change, that either means that they're the same or that log mode really was the best. So, right? Are we all good so far? Yes? Okay, perfect. Now, I look at what they gave me. Oh, yay. I look at what they gave me, and I look at my expectation here. Do I need to manipulate the function at all? No. I needed a plus b times the natural log of something. That's what they gave me. And then what they gave me, though, was x and y. I want to make sure I'm using this, so it's s of p equals, and then we're just going to write down what they have, but with 5 decimal places. So negative 91.54204 plus 29.90882 times the natural log of p, not x. Okay, make sure you're using the variables that we need to use. It's possible that on Desmos we have s and p, because remember, if we type in the equation, we can use whatever variables we want. But if we do a regression, they're going to give us x and y. Okay. Everybody with me so far? We're all good? Do we understand why we changed the first one, but we're not changing this one? Right? Because they tell me what to do, and I got to make it match. Okay. So then, using the model found in part A, what is the predicted annual salary in thousands of dollars for a pastor whose church size is 500 people? All right, is that 500 my input or my output? Input, right? Because the church size, and they told me, and I labeled it, church size, number of people, that's my input. So that means I want S of 500. I am not, even though I could, I am not typing this mess in. I'm using it's there if I had to, whatever, but I'm not doing that. It's there for me already. And in there, even though it's P for this function, it's really X on my computer, right? So when I go back over here, and I'm not sure if I guess I didn't hit that. There we go. Hit my little magnifying glass. Then I want to say, all right, I want to know what's happening when X equals 500. And then there we go. I get that vertical line. It's probably not a bad idea to zoom in just a little bit so I can click right there. And then I can see when X is 500, that's my answer. Okay, we all good with that? All right, so I'm going to come over here and write that is equal to 94.32954. And what does that number represent? Because 500 was people. The output represents what? Salary. Okay, so I got 94. Well, would it make sense that his salary would be $94? No, but 94 is the correct answer because it's what? Thousands of dollars. It says it right here. It also says it right here. Now, I could multiply by 1,000, but don't do that. Just write down whatever it says for the units. That is 94 point whatever thousands of dollars. So $94,000 makes a little bit more sense for a salary. Well, it makes a lot more sense for a salary. Okay. What questions do you have? We all good so far? Awesome. All right. So the most common and preferred method to measure sound intensity levels is in decibels, lowercase d, capital B. The sound intensity level, and then there's this, that's a Greek letter. Anybody know which one that is? Beta. Okay, if you don't know that it's beta, that's fine. You can still work the question just fine, but it's beta. So the intensity level, beta, in decibels, of a sound having intensity I in watts per meter squared is modeled by this function. Now, if you're like, I don't know anything about decibels, beta makes me a little uncomfortable, and I have no clue what watts per meter squared is. Totally fine. This isn't a physics class. I mean, it says that stuff, but we just got to be able to do the math, and just you can make it make sense without overthinking it. So the beta, the decibels is my output. My input is the intensity level, okay? And A and B are constants. So this goes on. Oh, so here's a little fun fact first. Fun fact. The word decibel comes from two pieces. First, the deci, that is a prefix you should know. Like if you have a decade, how many years is that? 10. Decimeter, that's 10 meters, right? So it refers to the fact that the level of sound is multiplied by 10 as part of the formula. The bell part refers to Alexander Graham Bell, the inventor of the telephone, and the person that decibels is named after. So if you're ever on Jeopardy, there you go, you know something about decibels. All right, or if you're in physics and, whatever. Okay, so the sound of noisy traffic has the intensity level of 1 times 10 to the negative fifth watts per meter squared and corresponds to 70 decibels. Again, even if decibels, like I don't even know what any of that means, they have told us in things we can figure out that our input is the intensity, our output is the decibels. So I can make an ordered pair of 1 times 10 to the negative fifth, comma, 70. That's input, output. A loud concert has intensity of 1. That is not an I, but I totally see how it could be confusing because the I looks like a 1, but that's a 1. Intensity of 1 and corresponds to 120 decibels. So that ordered pair is 120. Okay, everybody good with all that? All right, so just as another little side note that we don't necessarily have to know to do this problem, 1 times 10 to the negative fifth, is that a really big number or a really small number? Really small number, because again, just to make sure that we know how scientific notation works, I take the 1, there's my decimal, -5 means I move to the left 5. Wait, I wasn't counting. 1, 2, 3, 4, 5. There's my new decimal, and then I put in my zeros, right? That's how we do scientific notation. So just a little reminder. Again, we don't even have to do it, but all right. And not only that, since it's 1 times 10 to the -5th, do I even really need the 1? No, because 1 times anything is itself, right? Okay, so we're going to use the data to write the 2 equations. And I'm based on this. So my output, 70, is equal to the input, not the input, I'm sorry, it's equal to A plus B, which we don't know, times the log of the input, which is 1 times 10 to the -5th. Okay. I'm still just going to write the whole thing, even though I don't need the 1. There'll be times where we can drop it, but I'm just writing my equations. Not overthinking anything. My next one, output 120 is equal to A plus B times the log of 1. I've written my 2 equations. Now I need to find A and B. All right, so let me ask you this. What is the log of 1? 0. Think about your parent function, right? If I input 1, my output's 0. So if the log of 1 is 0, then this whole term is 0, right? That means before I do anything, I know that A equals 120. Now, we're going to use the calculator. You wouldn't have to think through that. I'm just showing you that that's how it's working. The other thing is this. Log of, so 1 times 10 to the -5th. We already said it really could just be 10 to the -5th, right? So what is log of 10 to the -5th power? It's easy. Don't overthink it. What's the base of this log? 10. If the base matches this base, they basically cancel each other out, and you just get -5. Okay? That's a log property we need to know that can be very helpful. So I could totally do this one by hand very easily, but it is a calculator question. Let's go ahead and do it on the calculator so we can look at a few things as well. So let's go back over here and start anew. And so I'm using my ordered pairs of, so here's where you could put 1 times 10 to the -5th, but I'm just going to do 10 to the -5th and 1, and then 70 and 120. Okay, I'm going to zoom in. I'm going to hit that, and I'm going to do logarithmic. I don't have a log mode button. I almost wish it was there every single time so you'd remember to do it, but that's because I just have 2 points. All right, and then, but here's the thing. Is this what I want it to look like? No, it's supposed to be just log, right? So I'm going to go over here. What do I hit? The 3 dots. I export as a custom regression. I'm going to arrow over. I'm going to delete the natural log, and then just type in log, or if you're using this, we go find the log, hit that. I don't need a base, right? You could put base 10 if you wanted to. And then here's what we have. And look, it's 120, just like we knew. And this is a nice, pretty, oops. This is a nice, pretty number 10 because we could have done it by hand, nice and pretty. But again, we got the calculator. So A equals 120, B equals 10. Everybody good so far? Okie dokie. So then it says, the human eardrum can burst when sounds reach an intensity level of 1 times 10 to the 4th watts per meter squared. According to the model found above, what is the predicted number of decibels required to burst a human eardrum? Now, it does not say I need to do this here, but we're going to do it because it could be, you could be told to do it in another question. But I'm going to actually write out the equation. So it was beta. The way you write a beta is it's like a capital B, but it has this tail on it and it's curvy. So I would just kind of start from the bottom. That's a beta. Just do your best. Of I equals A, which is 120 plus 10 times log of the intensity. Okay. Now, we are supposed to find the predicted number of decibels. that could burst an eardrum based on what they told us. So is this right here, is this an input or an output? Input. So that means I want beta of 1 times 10 to the 4th. Now, although it's my input and it's the I here on Desmos, it's the X. So we're going to do the same kind of thing we did on the other one. We're going to come over here and say, all right, well, I want to know what's happening when X equals, and you could just do 10 to the 4th, but you can also do 1 times 10 to the 4th. I mean, you're going to get the same thing either way. Now, usually when we do this, we get a vertical line pop up and we're like, oh, look, there it is. I see nothing. But make sure you're paying attention to what is really going on here. Even if you didn't know what 1 times 10 to the 4th is, it tells you right there, it's 10,000. And that's your input. Look at your inputs, which I can't even see because they're way down there. My inputs only go to 1.5. So I need to go way the heck out there, right? So we need to zoom out. I'm going to keep zooming. That's just at 5,000. Now I'm at 10,000. There's my vertical line. For whatever reason, earlier today, I think in one class I had to, one class I didn't. To see where they intersected on one of them, no matter what I did, and maybe it's going to happen here too, and maybe it's my board. I don't know. I couldn't click on to make it gray. Well, it's not even gray. So I had to zoom in. I don't know why. And I didn't have to one period, and one period I did. So I don't know what's going on. There we go. You get the little gray dot so you know you're right there. Oh, that's 10,000 zero. That is not what I want. The heck, man. There we go, 10,160. Okay, everybody good with that? So that means my answer is 160, but it's 160 what? Decibels, okay? And so you could use the dB, or you could write out, the word decibels. Now, let's talk about doing this by hand, okay? Because in like on a multiple choice question or something else, maybe you'd have to. I've got, so what this would give me is 120 plus 10 times the log of 1 times 10 to the 4th, okay? Well, we know that 1 times 10 to the 4th is really just 10 to the 4th, right? And then log of 10 to the 4th would give me what? 4, because those essentially cancel each other out. So this gives me 120 plus 10 times 4. Well, that's 40 plus 120, and that's where we get 160 from. Okay. What questions do you have? Anything? All right, so there is a second part to this, even though it doesn't say that on there. So I'm going to give it to you. We're going to start it. We are not going to finish it today, which is totally fine. But this really models the FRQ pretty well. So that's why I want to work through this, or an option of the FRQ. I think that's 4. If not, I will come back. Did y'all have enough? Oh, thank you. Okie dokie. So this is also going on page 81. All right. So students who completed a class participated in a year-long study to see how much content from the class they retained over the following year. At the end of the class, students completed an initial test to determine the group's content knowledge. At time t equals 0, the group of students achieved a score of 75 out of 100. That tells me I have an ordered pair that is 0, 75. I'm going to go ahead and write that down. For the next 12 months, the group was evaluated at the end of each month to track their retention. After 3 months, t equals 3, the group's score was 70.84. So then I also have 3 and 70.84. Okay? Everybody okay with all that? Okie dokie. So then it tells me that the group's score can be modeled by this, which is yet a different version of the law, where R of t is the score in points, t is the number of months since the initial test. So it says to use the given data to write 2 equations. So again, that's pretty much, you're going to see that at the beginning of FRQ. So I say, all right, I'm going to use my first order pair. My output is 75. That's equal to A plus B, which I don't know, times the natural log of T plus the T is the input. I'm so sorry. The input, which is T, which is 0 plus 1. Now, do you know what 0 plus 1 is? Yes. Great. Nobody cares. Where I'm not going to put 1, I'm putting 0 plus 1, and I'm leaving it. I don't need to overthink it. I don't need to fix it. Okay. Then I do my next one. 70.84 is equal to A plus B times the natural log of the input, which is 3 plus 1. Okay. So I've written them. And then again, we could find them by hand, but we don't need to. It's a calculator question. Let the calculator do it for you. Okay. So we're going to go in here. I'm going to X all this out. I'm going to start a new table. And I'm going to type in my numbers. Let's see, I had 0 and 3. 0 and 3. And then I had 75 and 70.84. Okay, everybody good with those? I'm going to zoom because my zoom is real weird now. So I kind of like that this does this automatically. I really like that it does it automatically. And then regression, logarithmic. Uh-oh, we got a problem, right? First time we've seen this. We're waiting for a log mode button and we got this stuff. But look, if you get something like this, click this, it tells you stuff. It says logarithmic regressions only work if the first column is all positive numbers. So let's think about this. Remember, what it's going to give me when I choose this is A plus B times the natural log of X. No matter what else I want, that's what it gives me. So it's trying to take the natural log of 0. Can you do that? No. So there is a way for me to tell it, hey, I want it to be natural log of X plus 1 or whatever, but then I have to know how to write all that stuff. I don't want to do that. So instead, and I know this is a little weird, but there's a chance that something like this comes up. Since it's doing that, but look what I want. I don't want just natural log of T. I want of T plus 1. That's why it works. So since what I really want to take the natural log of to get this is the T plus 1. If that happens to us, then instead of using 0 and 3, in order to make it work, we need to actually go ahead and add in the 1. So I need to change the 0 to 1, and I need to change the 3 to 4. Okay? Now, here's the way I want you to kind of keep all this straight, because sometimes we adjust the numbers in the table, sometimes we adjust the equation. We are not doing both, all right? So here's what I'm not doing. I am not going in here and changing and doing the 3 dots and changing this to X plus 1. Not doing that, okay? Instead, what I have, technically what I have right now is X plus 1. You agree with that? Like it says X, but what I did is X plus 1. You with me on that? So that means that these two things here, those are my numbers. And since this is X plus 1, that's what that X represents. It represents X plus 1. So this is my equation, except I have to make sure I write X plus 1. So I'm going to go over here, and I'm going to say A plus B. So A is equal to 75, and B is equal to the B it flat out gave me, which is negative 3.00081. Do you understand why we did what we did? So we either adjust the equation or we adjust the numbers in the table. We don't do both. Okay? I think that's probably the easiest way to remember that. And so when we have to, if you adjust what you're taking the log of, that's when you have to adjust the table. And then I want to show you one more thing before we stop. So if you look up here, 70, I'm supposed to have a point that's 0.75, right? 75 is right there. I don't have the point 0.75. So this function that it gave me, this is not right, right? And if I adjust it like I did before, that's not going to work. So I have my answer. The other way you can get an equation here, so remember, if I hit the 3 dots, I can export. I don't want to do that. I don't want to change the regression. What I want to change is the actual equation, but leave these numbers. So you see this little thing that says equation? It plops that down there. So when you plop it down there, now I want you to see if you change that to X plus 1, do you see how you have 0.75? and the green one is the correct function. Okay? So we had two options. I went with, let's go with the calculator and know how to manipulate that, rather than being confused about when I'm supposed to do it by hand and when I'm supposed to use the calculator. Okay? I think overall that's going to be better. We will revisit this one tomorrow because we don't have time to finish. And so we'll kind of start over and just talk through that again to make sure we get it. All right? We good to go? All right, good for today.